Welcome friends, I am Tanmoy. I welcome you all in my channel Chemistry, the Mystery of Molecules. So today I shall discuss about Cumene phenol reaction or Cumene phenol process, or even some people say Cumene phenol rearrangement. So this reaction is nothing but conversion of benzene into phenol. Okay. So today we are going to discuss about this, for this reaction, role of acid, role of pressure. You can see lots of places pressure are there, reaction mechanism, acetone and its use, and finally p-benzoquinol preparation. Okay, so let's start. So this reaction is finally conversion of benzene. So this is benzene, you all know, into phenol. So what happens, for example, you can say this hydrogen is replaced by this OH, this is produced, and along with this it produces another important byproduct, that is acetone. We all know acetone is a very important reagent in laboratory as well as industry. So this is the advantage of this, and this is the success of this, that this process produces two value added chemicals. Once this is phenol and this is acetone. Fine. So here how this reaction is happening. So this reaction is happening first in stepwise. If we say, I will explain mechanism later. First, this reaction is reacting this benzene with this propene. Okay, this propene, and ultimately this is producing. In second step, it is reacting with oxygen under little pressure, and finally work up means acid. Better to say it is sulfuric acid. Okay, so instead of H3O plus, it is better to write directly. Actually, sulfuric acid is used, and it produces that final product acetone. Okay, so first let's discuss about acid. Why here phosphoric acid and here sulfuric acid? So why phosphoric acid is here? Because we know if we use sulfuric acid here, it means at the first stage there is an unexpected sulfonation as chance. But in case of phosphoric acid, no sulfonation occurs. That is the reason for using this phosphoric acid. So first point over. Second, 250 degrees centigrade fine temperature is needed and 30 atmosphere. Why? Because this is a gas. This is a gas. Another thing, this is a gas, if you increase the pressure according to last Laplace principle, the equilibrium will shift right side. I will explain the mechanism. It will be clear more on that time. So this pressure helps, and this reaction is actually Friedel-Crafts alkylation. I will explain. Next step, this oxygen, this is also a gas, so ultimately little high pressure required, and third is sulfuric acid, so acid catalyzed rearrangement. Okay, so let's discuss about the mechanism part. What happens? This means propene. What happens? Propene reacts with acid, means H plus from phosphoric acid, and this phosphoric acid don't produce any phosphorylation product like sulfuric acid, which results in sulfonation. No phosphorylation happened in the phosphoric acid. So what happened after this? It produces CH3, because if proton is attached to this carbocation, now it's relatively stable. Okay, so this is the electrophile. This is the electrophile. And what happens? This electrophile reacts with benzene, and that reaction is named as aromatic electrophilic substitution. Okay, so in this way, finally this is produced. I am not explaining the mechanism of this aromatic electrophilic substitution because it's very easy, and another thing, in future I will make a dedicated video on aromatic electrophilic nucleophilic later. So right now just this is. So this is fine. Now what happens? So here you can see after product, this is produced through aromatic electrophilic substitution. So this reacts with oxygen, and whatever we tell about oxygen we think okay, it's a OO double bond we consider, but actually it is not. It remains OO single bond with one unpaired electron on this oxygen, one on this, and this is why this oxygen is called triplet oxygen. Why? Triplet oxygen. Why? Because the lone pair you can see not lone pair, the unpair, there are two unpaired electron on this oxygen. That's why spin multiplicity, that is 2s plus 1. Here this is half, so ultimately it's a 3. That's why it's triplet. There is another type of oxygen which is, this is paired, means this it is, and it is actually it's a double bond. So this is spin multiplicity is 1 and this is singlet oxygen. Okay, so for your information I want to say you that single oxygen is not good for us. It is poisonous for us. It could be specially generated using a dye like rose bengal. I'll explain this factor in another video. So in this way, this is the difference between triplet and singlet oxygen. So what we are using actually, this is a triplet oxygen. Okay, this is a triplet oxygen. And since this indicates that it has two unpaired electron. So that means it can act as a diradical. I repeat, since this oxygen has two unpaired electron, so it can act as diradical, and that is the reason why this reaction occurs. So what happens? This radical, for example, if you consider from here it is, and here it is, and this here, and these are called fish hook harrow, means movement of one electron. Keep it in mind. So here a radical is generated. So this, not only oxygen, if you use any free radical initiator, then also reaction will happen. Then why oxygen? Because it's a cheap. In atmosphere 20% oxygen is there, so better to use oxygen, cheap material. So this is a first step, it is acting as a free radical initiator. So what happens? This produces a radical species, or more specifically we say this is a benzylic radical. Fine. Benzylic radical means stabilized through resonance of this benzene nucleus. Along with this is CH3. This is actually CH3. So 3, 3, 6 hydrogens are also available for hyperconjugation with this. So it can stabilize. So in this way, this radical is stabilized. But always keep it in mind, resonance is more powerful than hyperconjugation. One exception is there, that is tertiary carbocation versus benzylic carbocation. Okay, where tertiary is more stable than benzylic. Benzylic stabilized through resonance, tertiary through hyperconjugation. I have made a dedicated video about it. Please go through it. So fine, radical is generated. Now what happens? So when radical is generated, you don't be confused. What happens with these oxygen? These oxygen also formed with this. Okay, this is the fate of after this proton abstraction. This is produced. So we will not focus on this. So this, and here again there is oxygen, means triplet oxygen. So these will react. These will react. So in this way, what will be there? One radical will remain, and these two will react and form this O bond. Okay, it's like a hydroperoxide radical. Okay, this is this is the hydroperoxide radical. Okay, I'm not right. So what happens after that? See, first step is phosphoric acid to get this. Second step is oxygen, we got this. Third step is acid. So here H2SO4 means acid. So here OH will be produced, and one another thing. Now question, what is the need of this 5 atmosphere pressure? First of all, oxygen is gas. Second of all, it is essential to keep this peroxide species in liquid state. Okay, that's why this, another thing is that this high pressure helps to do this, because hydroperoxide are very dangerous and explosive material, because this bond can break this O bond and it may result explosion. So this is such kind of one type of explosive. So first this, and second, since additional hydroxide is there, and we know that there is a one term called as alpha effect. What does it mean? Means repulsion of this lone pair among these two lone pair makes this is more reactive and more nucleophilic. As well as we can say that it can undergo protonation relatively easier, because after protonation this repulsion will reduce little bit. I guess say little bit, but it will be reduced. So what will happen? It will be protonated in presence of second molecule of H plus produced from this sulfuric acid. Fine. Now the important thing or interesting thing, that is Cumene phenol rearrangement. What happens? This here, this is OH2. So it will leave, since the leaving group means after leaving of what means OH, water is a neutral leaving group, and I have made one video about the nature of leaving group regarding the substitution reaction. So please see that. Okay, it will be clear for you. So if it leaves, what will be the product? So positive charge will come here. And another thing, oxygen is electronegative atom. So it will not like to have positive charge on it. What will happen? So someone will migrate. Chances. What are the alternate options? So this can migrate or this phenyl can migrate. But the migratory aptitude, or in word if we say the tendency of migration, is more in case of phenyl. Okay. So consequently, this phenyl group means this phenyl group will migrate. And what will be the product? So if this phenyl group migrates, then positive charge will be developed here. So ultimately, this is methyl, this is positive charge attached with oxygen, and here is this benzene. Fine. Now, in this context, I want to give you one information. What information? How this is happens. For example, if I draw it again, this is the methyl, this is oxygen, this is OH2. Let's consider this OH2 is, and for your understanding, it is not the reality. So let's consider this is left, so positive charge is here, and this is double bond. So what happens? How benzene? Why phenyl is more efficient for this migration? Because this pi bond attacks here. Consequently, what happens? If this pi bond attacks here, then this bond will eliminate, and there will be a bond formation here, and positive charge is here, and that positive charge is resonance stabilized throughout this benzene ring. Means if I draw it properly, it should look like not this, it should look like this. So that is the reason why phenyl is more efficient in migration, because it can hold the positive charge. It can hold the positive charge during the migration due to the presence of its pi electron. Okay, fine. So this is fine. After that, what happens? Now you can see there is a carbocationic center, and this is resonance stabilized. Why? Because we know carbocation, this center is a 6 electron species, so electron deficient, but the neighboring oxygen has lone pair of electron. So it will give the lone pair of electron and provide a resonance stabilization. What I say, this is methyl O, this is pH, resonance stabilization. So in this way status. Now you can say negative positive charge on oxygen, how it's stable? It is relatively stable. I say a word relatively stable compared to this deficiency. It is also electron deficient, but relatively stable. Okay. So what happens after that? Water molecule. We will write HOH. Okay. Water has a lone pair and it will attack. Now you can see, consider it's a carbonyl compound and oxygen is protonated. Why this reaction is happening? Because due to this charge, the electron deficiency, this center is more electron deficient. Or you can think it in another direction, it's a 6 electron species, so water can attack carbocationic center. So water attacks. What happens? What it produces? It produces this methyl. This is OH after the elimination of protons. After attack, this oxygen will be positive charge, so it will eliminate protons. So I am writing H plus elimination. This will be pH. Fine. Okay. And you can see this is a gem diol, that means hemiacetal type. Okay. So in acidic condition, we know that hemiacetal are not stable in acidic condition. So first it will be protonated, this part portion. Second, this oxygen pushes lone pair and it will eliminate. So what will be the product? If this pushes its lone pair and it's eliminate, it will produce acetone. One product CH3COCH3. And second is which is phenol. Okay. So that what you have read, this phenol and acetone, in this way it is produced. So overall, what is happening? This oxygen, actually what is produced? This oxygen is providing one oxygen atom for this and another molecule. For example, here you can consider this is a dehydrated version and this takes one oxygen. So this one oxygen is distributed in these two ways. What is about the hydrogen? This hydrogen when I'm not saying it is happened, but you may think that balance is here. Okay, it's a rough understanding. Okay, fine. Now we have discussed about the mechanism. Now question, what about the acetone? Actually, if this process is highly beneficial when both this acetone and phenol has market demand, means it is important. But if we don't need acetone, so or it is not that much needed for us, can we utilize it? Means in industry they don't throw anything, everything is important for them industry, and they want to recycle everything to reduce the cost as well as environmental hazard. Please keep it in mind, nowadays environmental hazard is an important factor in industry. Okay, so what they do, they reduce this acetone, CH3COCH3. Reduce to that, we know this reduction of this acetone results in isopropyl. Fine, CH3, and dehydration of this isopropyl, for example, in presence of phosphoric acid. So what it produces? It produces, so this first what will happen? These will be protonated. It will lead producing a secondary carbocation, and then one hydrogen will be emitted from here or here. So ultimately, what will be the product? This. So see, the exactly same product we can prepare. So actually, we are recycling. So if acetone is not needed as industrial important product, then this could be recycled to prepare the propene. Sorry, this should not be CH2. It could be recycled to prepare the propene again and could be used for this purpose. So in this way, reaction could be carried out. Okay. So now let's discuss about the p-benzoquinol. Okay, let's continue the discussion. So you can see, instead of cumene means isopropyl benzene, we have taken diisopropyl benzene. Okay, how this could be obtained? This could be obtained from corresponding benzene itself by means dialkylation. Okay, so we know that alkylation of any benzene moiety increases electron richness. So in this way, this could be done. Another thing, it's a bulky. So this means alkyl group, we know ortho and para detecting. So if due to the bulkness there will be some para isomer there, so it will be preferred to have this aromatic electrophilic substitution on the para side. So in this way this could be prepared. This is the logic behind the preparation of this molecule. Fine. So similarly, in presence of oxygen under pressure and acid, this Cumene Phenol process following it can produce p-benzoquinol. Actually, we are right now discussing about the p-benzoquinol preparation and other material preparation application. Okay, so p-benzoquinol, and this is the acetone, but here you can see there will be two molecules of acetone. Why? Because here two substitution is there. As what is the easiest way to remember? Just break this, put OH, and this part double bond O. So easiest way, this is the tricks to remember or write the product. Okay, fine. If you can remember the mechanism properly, that's very good, best. But if you can't, this could be a tricks. Okay. So the second example, see, previously we have taken isopropyl benzene, means previously we have taken this. Right now what we are taking this. So what will be the product? Such type of thing could be given in your question to confuse you. So always keep it in mind, reaction is proceeding through the carbocation. I have explained the mechanism, and more stable carbocation will prefer to form. So if this is given, there is a chance carbocation will form here, protonation will be here. So ultimately it will attach. So what will be the product here? In this case, the product will be this. Fine. And another, as I told in case of previous thing, that this part should be OH. So one part will be, this part should be of OH, and this part should be double bond O. So what will be the product? Product will be this butanone. Okay. So here one carbon, this is butanone, plus product is phenol. Fine, keep it in mind, it will be useful. But for example, instead of this, if it is given to you, means for example this is R1 and this is R2. Now both are secondary. If the protonation happened instead of this, it's a terminal alkene, instead of this some internal alkene is given, there is a chance of both secondary carbon formation. Then there will be mixture of carbonyl compound. For example, what do I mean mixture of carbonyl compound? Means it could be, means this could be added to this or this. Okay, both. So what one will be this oxygen R2, and what will be the another? Another will be this. So there will be, ultimately there will be a mixture. Okay, so I guess you have understood the fact. So based on this concept, can you propose the synthesis of beta-naphthol using this Cumene Phenol process? Actually, we can propose. So how? So we know that if we go the back direction, this is produced from the corresponding isopropyl derivative. As I told, try to follow this trick. So what will be the thing? So here you can think that this will be prepared. This is oxygen. So this is oxygen, and another thing, this is carbocation. Fine. How it could be prepared? It could be prepared from corresponding, means after rearrangement. So I am going to back direction. So this is also a proof that whether you have understood the video properly or not. If you understood, you can do. If you don't understood, I suggest you pause the video here, go back, study again, and come back and continue this understanding. So find how. So this, how it could be prepared? It could be prepared from Friedel-Crafts alkylation of this naphthalene along with this propene. Okay. So now one question may come. Is it 2? This is sometimes called 1 or 2, or alpha or beta. Both type of naming are there. Why beta? Because it's a thermodynamically controlled product. One is kinetically controlled product. Okay. So I will explain in future about this. Why this is thermodynamic, why it is kinetic. So this is more stable since thermodynamic. So ultimately it will be produced as the product. So in this way, beta-naphthol could also be prepared from this Cumene Phenol process. This is called beta-naphthol. Okay. So this is the overall discussion about Cumene Phenol process, about basic concept and mechanism. In next video, I will explain about some other example related to Cumene Phenol process. So what we have learned today? We have learned first the Cumene Phenol process basic concept, the role of acid, the role of pressure, means pressure of propene and oxygen, reaction mechanism in details, everything, and acetone and its use, and finally para-benzoquinol and some tricks how to solve or think, how to keep it in mind this process, and some other 2 examples. Okay, so this is the end of discussion. If you like my teaching, please give a like, share this video among your friends such that many people could be benefited from my effort, and finally subscribe my channel Chemistry the Mystery of Molecule, and please press the bell icon to get the notification of every single video I upload. So see you in my next video.